For today, let's look at this interesting inequality question. Here is the question. Suppose x is a real number and x is not equal to 0, x is not equal to 1. We also find the maximum value of m and the minimum value of n such that 2 to the power x minus 1 over x to the power of 1 over x minus 1 is in between m and n. Please have a good try before you look at the answer. As usual, before we go and get the actual value of m and n, let us have a sense of what could be possible value of m and n. As shown, now we use Excel and check that what could be the value of this expression 2 to the power of x minus 1 over x to the power of 1 over x minus 1 for various value of x. So as you can see, if x equals 2, answer equals to 1.5. And now we check for some integer value of x from 2 until 400 plus. Now other than x equals to 0 and x equals to negative 1, you should also check for negative value of x. So let's try for this. Based on the calculation that we have just now, it seems that m is equals to 1 and n equals to 2. Because the calculation that we have for various value of x, the expression 2 to the power x minus 1 over x to the power of 1 over x minus 1 seems always 1 point something, and therefore it's in between 1 and 2. But this is only a guess. How are we going to prove that? I have tried various standard technique in inequality, such as AMGM inequality, Cauchy inequality, but none of these help. And now, let's try to use a technique in calculus, in particular, the mean value theorem. So the mean value theorem states that if f is a function that's continued on the closed interval AB and differentiable on an open interval AB, then there exists some c in AB such that f prime c equals fb minus fa over b minus a. In short, we say that mean value theorem as MVT. So now let n be a real number and let ft to be t to the power n, where t in between 1 and 2. Clearly, ft is continuous on the closed interval 1, 2 and differentiable on open interval 1, 2. And the derivative of f is n times t to the power of n minus 1. Using mean value theorem, there exists y in between 1, 2 such that f prime y equals f2 minus f1 over 2 minus 1. Using the definition of ft and the f prime t that we obtain, we have n times y to the power of n minus 1 equals 2 to the power of n minus 1. And this means that y equals to 2 to the power of n minus 1 over n to the power of 1 over n minus 1. Since y is in between 1 and 2, so this expression also in between 1 and 2. And now we obtain the following inequality. Note that n is just a real number, so we can replace n by x. And we have the following inequality. And now we confirm that the maximum value of m is 1 and the minimum value of n is 2. Hope that you learned something new and enjoyed this video. That's all for today's lesson. I'll see you again next time. Bye bye.